let's run through some examples that involve solving equations that have decimals. In the previous video, we learned that when we have equations with fractions, we can actually clear those fractions or get rid of the fractions by multiplying every single term by the least common denominator. And this makes then the arithmetic a bit easier when you're actually doing the solving. Well, there's a similar strategy you can use with decimals. You can work on the equation with the decimals, and if you have access to a calculator, that's often the fastest way to solve the problem. But you can also clear or get rid of the decimals, and this is really helpful if you are asked to solve a problem without using a calculator. So let's take a look at the equation negative 4.5x plus 1.2 equals x plus 0.7. Notice that all of the decimals in this problem have just one digit after the decimal. All of the numbers have just at most one digit after the decimal. These decimals all have digits in the tenths place. So if I want to get rid of or clear the decimal, I can multiply every single term by 10. Multiplying by 10 actually takes that decimal and moves it one place to the right. So if we multiply every single term by 10, this negative 4.5x, the decimal moves one place to the right, and it turns into negative 45x. Plus 1.2 times 10, the decimal goes one place to the right, that becomes a 12. Equals, now on the right-hand side here, the first term is just an x. We do have to multiply that by 10 as well. So 10 times x, 10x. Plus, and then finally 0.7 times 10, moves the decimal one place over, is just 7. So now I have the problem negative 45x plus 12 equals 10x plus 7. If I want to put all the constants on the right side and the variables on the left, we could start by getting rid of this plus 12 on the left. To do that, we minus 12 from both sides. Now I have negative 45x equals 10x, and then 7 minus 12 is minus 5. I want all the x's to go on the left side, so I'm going to subtract 10x from both sides. So negative 55x, that's minus 45x minus 10x, is negative 55x equals negative 5. Finally, to get x by itself, I divide both sides by negative 55. So x equals negative 5 over negative 55. We have a negative divided by a negative, so that's going to be a positive number. And this is a fraction that we can reduce. 5 and 55 are both divisible by 5. 5 divided by 5 is 1. 55 divided by 5 is 11. So final answer, x equals 1/11. Here's another example. 0.05x minus 0.2 equals 1.2 minus 0.3x. Now in this problem, I notice that there is a number. In fact, this first term has two places after the decimal. 0.05, the 5 is in the hundredths place. And so if I want to clear decimals and I have two places after the decimal, I have to multiply by 100. So I'm going to multiply every single term in this equation by 100. And that's going to take the decimal and move it now two places to the right. So 0.05x times 100, the decimal goes two places to the right, and that becomes 5x. 0.2 times 100, the decimal goes two places to the right, and that turns into a 20. So left side is 5x minus 20. 1.2 times 100, again the decimal goes two places to the right, that's 120. And then finally 0.3x times 100, the decimal goes 2 places to the right, that is a 30x. So my equation is 5x minus 20 equals 120 minus 30x. If I want to put the constants on the right, I'm going to add 20 to both sides. So now I have 5x equals 120 plus 20 is 140 minus 30x. If I want the x's on the left, we want to get rid of the minus 30x, so add 30x to both sides. Our equation is now 35x equals 140. Finally, divide both sides by 35. So x equals 140 divided by 35. This is something we can definitely reduce. 140 and 35 are both divisible by 7. 140 divided by 7 should be 20. 35 divided by 7 is 5. So 20 over 5, I can go even further with that. 20 divided by 5 is 4, and that would be my final answer. That was my last example. Please reach out if anything is unclear.